Lalande 21185 is a red dwarf in the constellation of Ursa Major. Although relatively close by, it is only magnitude 7 in visible light and thus is too dim to see with the unaided eye. The star is visible through a small telescope. At approximately 8.31 light-years away, it is one of the nearest stars to the Solar System, only the Alpha Centauri system, Barnard's star, and Wolf 359 and the brown dwarfs Luhman 16 and WISE 0855-0714 are known to be closer. Because of its proximity, it is a frequent subject for astronomical surveys and other research, and thus is known by numerous other designations. Research papers most commonly use the designations BD +36 2147, Gliese 411, and HD 95735 to refer to this star. In approximately 19,900 years, Lalande 21185 will be at its closest distance of about 4.65 light-years from the Sun. History. The celestial coordinates of Lalande 21185 were first published in 1801 by French astronomer Jérôme Lalande of the Paris Observatory in the Star Catalogue. Histoire céleste française. The catalogue sequence numbers for majority of the observed stars, including this one, were introduced in its 1847 edition by Francis Bailey. Today this star, along with a few others, is still commonly referred to by its Lalande catalogue number. In May 1857, Friedrich Wilhelm Argelander discovered high-proper motion of the star. Sometimes it was called Argelander's second star. Friedrich August Theodor Winnacher is reported to have made the first measurement of the star's parallax of 511 arc-seconds in 1857 to 1858, and thus first identifying Lalande 21185 as the second closest known star to the Sun, after the Alpha Centauri system. Since that time, better measurements have placed the star further away, but it was still the second closest known star system until the discovery of two dim red dwarfs, Wolf 359 and Barnard's star, in the early 20th century using astrophotography. Physical properties. Lalande 21185 is a typical Type M main sequence star with about 46% of the mass of the Sun and is much cooler than the Sun at 3828 K. It is intrinsically dim with an absolute magnitude of 10.48, emitting most of its energy in the infrared. Lalande 21185 is a high proper motion star moving at about 5 arc-seconds a year in an orbit perpendicular to the plane of the Milky Way. The proportion of elements other than hydrogen and helium is estimated based on the ratio of iron to hydrogen in the star when compared to the Sun. The logarithm of this ratio is -0.20, indicating that the proportion of iron is about 10⁻⁻0.20, or 63% of the Sun. The surface gravity of this relatively compact star is approximately 65 times greater than the gravity at Earth's surface, which is more than twice the surface gravity of our Sun. Lalande 21185 is listed as a Bidraconis-type variable star in the General Catalogue of Variable Stars. It is identified by the variable star designation NSV 18593. Several star catalogues, including SIMBAD, also classify it as a flare star. This conclusion is not supported by the primary reference these catalogues all use. The observations made in this reference show that it is rather quiet in comparison to other stars of its variable type. Lalande 21185 emits X-rays. Claims of a planetary system. In 1951, Peter van der Kamp and his student, Sarah Lippincott, claimed the astrometric detection of a planetary system using photographic plates taken with the 24-in refractor telescope at Swarthmore College's Sproul Observatory. In 1960, Sarah Lippincott repeated the 1951 claim of a planetary system, only this time having different parameters. She used the original photographic plates and new plates taken with the same telescope. Photographic plates from this observatory, taken at the same time, were used by van der Kamp for his erroneous claim of a planetary system for Barnard's star. The photographic plates made with the Sproul 24-in refractor, and used for these and other studies, were later shown to be flawed. The claims of planetary companions for both stars were refuted in 1974 with astrometric measurements made by George Gatewood of the Allegheny Observatory. In 1996, the same George Gatewood prominently announced at an AAS meeting and to the popular press the discovery of multiple planets in this system, detected by astrometry. The initial report of a planet was based on a very delicate analysis of the star's position over the years, which suggested reflex orbital motion due to one or more companions. Gatewood claimed that such companions would usually appear more than 0.8 arc-second from the red dwarf itself. However, a paper by Gatewood, published only a few years earlier, and subsequent searches by others, using coronagraphs and multi-filter techniques to reduce the scattered light problems from the star, have yet to positively identify any such companions, and so his claim remains unconfirmed and is now in doubt. Refining planetary boundaries. This star's measured radial velocity is so constant that astronomer and planet hunter Jeff Marcy uses it as a perfect example of normal red dwarf stability levels. The negative results of this and other surveys do not preclude the presence of a planetary system entirely, but they do set an upper boundary on the mass of any planets that might be present. The detection limit by current technology for this star system is a little less than the mass of the planet Jupiter. New Earth and space-based instruments will certainly lower this limit further and possibly detect any small planets that may be present. The habitable zone for this star, defined as the locations where liquid water could be present on an Earth-like planet, is at a radius of 0.11 to 0.24 astronomical units, where 1 astronomical unit is the average distance from the Earth to the Sun.